In part 2 of our 5.2 binomial probability series, we're going to talk about methods for finding binomial probabilities and learn how to use our calculators to do so. The first method that we're going to see is the binomial probability formula. Now, it's listed here, and we saw it in section 5.1 as well. We have n factorial divided by x minus n factorial times x factorial times p to the x times q to the n minus x for numbers x, 0, all the way up to whatever the n is for your sets. Now, I'm showing you this to expose you to it. However, we are going to use our calculator instead of this formula. You will not be able to be required to use this formula at any point in time. And when you look on your MyLab homework, if you're doing a problem and you go to the question help and you see this formula, I want you to go to your notes for section 5.2 and we'll look at a table today that shows you some calculator formulas that you can use instead of it. For those who are interested in the derivation of the formula, this is extra. You're not responsible for reproducing any of this, but the first part of the formula, n factorial over x minus n factorial x factorial, represents the number of outcomes where exactly x successes occur among n trials. And the second part of the formula, p to the x times q to the n minus x, represents the probability of x successes among n trials for any one particular order. And when you see this exclamation point here, that's called factorial. So if I have 5 factorial, what that really means, it's shorthand for 5 times 4 times 3 times 2 times 1. If I have 7 factorial, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. It's all the numbers leading up to the number you're doing the factorial of, multiplied together. Like I said, we're going to use technology instead of the formula. So in your calculator packet, but also here in your notes, you can see the calculator steps. So the probability of x successes in n trials would be second vars binom PDF of npx. Some calculators use the down arrow instead of a comma. So if you have a menu, you'll be using the down arrow instead of a comma. And you want to read carefully because on some of our calculators, binom PDF is at 0, and on some of our calculators, it might be A. So make sure that it says binom PDF because we'll also be using binom CDF. As an example, if I wanted to find the probability of 6 successes in exactly 11 trials, where the probability of success was 0.4, I would go second vars, and then I would scroll down until I got to binom PDF, which on my calculator is A. Then I'll press enter. My number of trials is 11. Probability of success is 0.4. That would be given to you in the problem. And I'm finding the probability of exactly 6. And then I will calculate and then press enter. And I'll have the probability of 6 successes in 11 trials is 0.147. If you are a person that does not have a menu on your calculator, what will happen when you press binom PDF is that you're going to get this binom PDF part on your screen. You'll type in 11, comma, which is right above the number 7, 0.4, comma, and then 6, close parentheses, and enter. Using technology, we can find different types of binomial probabilities. It doesn't have to just say probability of x equals A. That's the one we just went over. So this table here is going to be really useful to you in this section. So if we're doing the probability of x is exactly or equals a number, that's where we're using binom PDF. All of these can be found using the second vars button that I just went through with you on your calculator. But note that we're only using binom PDF when the problem tells us equals or exactly, so x equals A. We also could be finding the probability that x is at most A or less or no more than. Then we'd have the symbol we have right here, x is less than or equal to A. In that case, you're going to use binom CDF of NPA. Now the complement to less than or equal to would be more than. So if you're finding the probability that x is more than a number, we have to do 1 minus binom CDF of NPA. These are complements. That means that their probabilities sum to 1, as we can see right here. Now, our calculator only finds probabilities going from 0 up to a certain number, so it only works from the left side shading. So that's why we have to use complements if we have probability of x is greater than a number. Another set of complements we could have would be for the probability that x is less than a. In that case, we're using binom CDF, NP, and then a minus 1. Because if we're saying less than a certain number, say probability that n is less than 4, well, it couldn't be equal to 4, but it could be 0, 1, 2, or 3. So in that case, instead of a, you're putting a minus 1. The complement to that would be the probability that x is greater than or equal to a particular number a. In that case, we're using the complement, 1 minus binom CDF of NP a minus 1. Here's some helpful information that might help you understand. Binom PDF stands for Binomial Probability Distribution Function. Use this when you're finding a binomial probability where x will be exactly one particular number. Whereas binom CDF stands for Binomial Cumulative Distribution Function. Use this when you're finding a binomial probability where x will be in some range of numbers, so it's a cumulative. For example, the probability that x is less than 4 will be the probability of x is 0 plus the probability of x is 1 plus the probability of x is 2 plus the probability of x is 3. Well, we could do binomial PDF 4 times, once for 0, once for 1, once for 2, once for 3, and then add all those together. But fortunately, we have this CDF function that will do all that for us, so we do less work. It's time to go back to the Twitter problem. Given that there's a 0.85 probability that a randomly selected adult knows what Twitter is, use the binomial probability formula to find the probability that when 5 adults are randomly selected, exactly 3 of them know what Twitter is. That is, apply the previous formula to find P of 3, given N is 5, X is 3, P is 0.85, and Q is 0.15. So we're finding the probability of X equals 3. For any binomial probability problem, my first step is to write P of X equals, or P of X is greater than, or P of X is less than equal to. You want to write what you're finding in symbolic form. Because then if you get stuck, you can always go back to that table we just talked about, and it will help you determine what calculator skill that you can put in. Now, for those of you who are interested in using that formula, like I said, you don't have to. There are quicker ways to do these problems. Here is how we would fill in the formula to get our answer. And you can see using the formula, we come up with 0.138. We're going to get the same thing momentarily using our calculator. Whenever you do any word problem in math, it's good to know what you know. We know N is 5, X is 3, P is 0.85, and Q is 0.15. We need to know P of X equals 3. Using our technology, because it's an equal to sign, we're going to have binom PDF. And when we use binom PDF, we have to put N, P, X. Our N is 5, because there were 5 subjects. Probability is 0.5. And then our X value is 3. So in our calculator, we're going to do second vars binom PDF of 5.85, 3, enter. And we should get 0.138. Second vars binom PDF, and we will have 5, enter, 0.85, enter, 3, enter. And we get our 0.138. Looking back at the quiz show problem, we have the Wheel of Fortune and roulette wheel is 36 slots, one of which is gold. If the ball lands in the gold slot, the contestant wins $50,000. No other slot pays. What's the probability that the game show will have to pay the fortune to 3 contestants out of 100? So we're looking for the probability that X equals 3. Our N value equals 100. The probability of success, P, equals 1 over 36. So what is our binomial probability? The probability of 3 successes in 100 trials will be binom PDF of 100, 1 over 36, 3. And it's equal to 0.225. When you type into your calculator, you can simply type in 1 and then press your division sign and then 36 to leave your answer as a fraction for that probability line. And it's always a good idea to avoid rounding where you can in the middle of your calculations. Our last example for part 2 is a devil of a problem. Based on a Harris poll, 60% of adults believe in the devil. Assuming that we randomly select 5 adults, we want to find the following. The probability that exactly 3 of these 5 adults believe in the devil, the probability that the number is less than 2, the probability that the number of adults who believe in the devil is at least 2, the probability of the number of adults who believe in the devil is at most 2, and the probability that the number of adults who believe in the devil is more than 2. What I want you to do now is pause the video, and I want you to write each of these statements in symbolic form. So what should that look like? Well, it should look like the probability of X, and then you'll write equal to, less than, greater than, less than equal to, or greater than equal to some number. Go ahead and pause, then we'll check our answers. We can use the cue words in each phrase in order to write our desired probability that we're looking for in symbolic form. For A, we have the word exactly. So we're going to write probability of X equals 3. For B, the cue word is less than 2. So we're looking for the probability of X less than 2. For C, our cue phrase is at least 2. So we're looking for the probability that X is greater than or equal to 2. The cue phrase in the fourth one is at most 2. So we'll have P of X is less than or equal to 2. And finally, we have more than 2 as our last key phrase. So we'll have probability of X is greater than 2. We can use our symbolic form now and go back to that table in our notes to help us figure out which calculator feature we should use in order to calculate our binomial probability. In this problem, we know that our selection is out of 5 adults, so n equals 5. We also know there's a 60% chance of believing in the devil for each of the 5 adults, so probability of success, P, is 0.60. For the first one, we're finding the probability of X equals 3. Looking at our chart, that means we should use binom PDF of NPA, filling in what we know. That gives us binom PDF of 5, 0.6, 3. And we'll get 0.436 for our answer, 0.346 for our answer. The next one, we're looking at the probability that less than 2 believe in the devil. According to our calculator formula chart, we'll be using binom CDF here with n, p, and a minus 1, because if it can't be equal to 2, less than 2, the greatest number would be 1, talking in integers. So we'll have binom CDF of 5, 0.6, 1. Let's put that in our calculator. We'll press second vars, and we'll scroll all the way down until binom CDF this time. On my calculator, it's B. And then we'll type in 5.6, 1, and we'll paste that, and we'll get 0.087. For part C, we're finding the probability that X is greater than or equal to 2. Well, that's the complement of our answer from B, where X was less than 2. So we can just take 1 minus our answer from B, 0.087, and we'll get 0.913 as our probability. That can also be written as 1 minus binom CDF of 5.61 equals 0.913. Use this as a guide as you complete the last 2 parts of the problem. Pause the video and find the probability that X is less than or equal to 2 and the probability that X is greater than 2. And then unpause the video to check your answers. Here are the answers. For part D, the probability that X is less than or equal to 2 is 0.317. And for part E, the probability that X is greater than 2 is 0.683. Note that this is the required work if you had a problem like this on an assignment.